Okay, so today we are going to learn the last part of probability, which is 7.4, solving problem using tree diagrams. Okay, so a tree diagrams can be constructed to show all the possible outcomes of an experiment. Each branch shows the possible outcome of an event. So let's take a look of the example. Okay, the example is a jar contains 6 red sweets and 4 green sweets. A sweet is drawn at random from the jar. If it is a red sweet, it is put back into the jar. Okay, this is the clue. If it's red, then it is put back. Okay, before the second sweet is drawn. If it is a green, then it will not be put back. Okay, so how do we calculate the probability? Okay, so what should we calculate? So let's look. A, 2 green sweets are drawn. B, a red sweet and a green sweet are drawn. So first, we need to draw this tree diagram. So first, we need to construct a tree diagram so that a problem can be clearly interpreted. So first, we need to see, we use R to represent red and G to represent green. Okay, so at first we have 6 red and 4 green, right? 6 red and 4 green. Okay, so we have 6 out of 10 probability that our first sweet is red. And we have 4 out of 10 probability, okay, that we choose our first sweet is green. Okay, after that, since if we draw red sweet, then it will be put back into the jar. So if we put back into the jar, so the content of the jar does not change. Okay, it will still be 6 red and 4 green. But how about this? If our first sweet is green, then it will not be put back into the jar. So the jar only left with 3 green sweets. Okay, so now if we look at red here, if the contents of the jar does not change, that means that the probability in the jar still be 6 out of 10 red sweets and 4 out of 10 green sweets. So if we take another red, then it will be this outcome. If we take another green, then it will be this outcome. And then, since the drawn green sweet is not put back into the jar, the new content is 6 red and 3 green sweets. So now the total number of sweets in your jar will be 9, right? Because 6 plus 3. If you take red, then it will be 6 over 9. If you take green, there will be 3 over 9. Okay, so this is how you look at the outcomes and how do you draw a tree diagram. Okay, so let's see. If 2 green sweets are drawn, okay, if 2 green sweets, okay, I use green color. Okay, I use green color. So green color, the first probability of green color is 4 over 10. And then after that, if you take 1 green and then you take second green, it will be, the second one will be, okay, second one will be 3 over 9. So these two probability, you multiply together, okay, multiply together, okay, because this is a intersection. So you need to use multiply, okay. So 2 green sweets are drawn, so 4 over 10 times 3 over 9, okay, then you will get 2 over 15. Okay, next, if you take a red sweet and a green sweet, okay, look this one, okay, it doesn't ask for the arrangement. So it can be a red sweet and a green sweet, or it can be a green sweet and a red sweet. Okay, so the outcome you need to pick is RG or GR. Okay, so if I pick RG, it will be this one and this one, 6/10 times 4/10. Okay, and then if I take GR, then it will be 4/10 times 6/9. Okay, then why do we use plus? Okay, because it's either this or this. Okay, it's either one of the possibilities. So we use plus. Okay, then if you plus all of it together, then you will get 38/75. Okay, normally if you are not that good with probability, we use this tree diagram. Okay, we use this tree diagram to help us. Okay, next, let's see the second one. Okay, the second one is 6 male members and 3 female members of the St. John Ambulance Society of a school are assigned to sell car stickers during the flag day. The following diagram shows the route taken by a van carrying the members. They are dropped off at random at various points along the route. Okay, so our starting point is this, going off to our market, going off to bus station and other location. Okay, let's change the color a bit. Okay, so if two members from 6 male members and 3 female members are dropped off at market, calculate the probability that both are male. Okay, calculate the probability that both are male. Okay, so first we use tree diagram, okay, to solve this. Okay, to solve this. So 2 people are chosen at random, considered choosing one after the other without replacement. Okay, so if you take male, okay, first member are chosen. Okay, you have actually, at first you have 6 male and 3 females. If you take one male out, then you are left with 5 male. And then the number inside, at first you have 9 people, now become 8 people, right? And then another choose another male, then it's 5 male out of 8 people. So your 2 probability will be 6/9 and 5/8. So the probability of both are male is 6/9 times 5/8. The answer will be 6/12. Okay, 6/12. Okay, or you can do like this by reasoning. We want to choose 2 males, one after the other, from 6 males and 3 females. So probability of choosing 2 male, choosing first male, and then probability of choosing second male. Okay, so first male is 6/9. Okay, second male is 6 minus 1 over 9 minus 1. Why? Because you already pick 1 male out from the 6 male, and from the number of people, 1 already gone. So now you're left with 5/8. Okay, you see, if I talk to you like this, it's hard for you to understand. But if you have tree diagram, it's easy for you to understand. Okay, so you can use this method, then you will still get 5/12. Okay, 2 people. Next, after 2 male members are dropped off at the market, another 2 more members are dropped off at the bus station. Okay, calculate the probability that at least one of them is female. At least one of them is female means, okay, there will not be both male, right? Okay, must got one female. So you can either be 1 female, 1 male, or both are female, right? Okay, you can either be 1 female, 1 male, or both are female, because it says at least ma. But one thing we cannot accept here is it cannot be both male. Okay, cannot be both male. So why not we just calculate the probability of both male, and then we use what? We use complement. Okay. So what is the probability if both are male? Okay, now male left with 4 people, right? Because 2 already gone, ma. And then the number of people inside left with 7. So first male times second male. So it's 4/7 times 3/6. So we have 1 minus 2/7. Why 1? 1 is guarantee everything will happen. Okay, guarantee everything will happen. But you don't want one thing happen. You don't want both male happen. Okay, you want everything happen minus both male happen. So then you're left with what probability? You're left with 1 female, 1 male, or both female, because there are no more both male. Okay, let me tell you again. Okay, 100% probability will have these 3 outcomes. Okay, first outcome is 2 male. Second outcome is 2 female. Third outcome is 1 male, 1 female. This one don't have female, I don't want. Okay, so my 1 minus this one. Then I have 1 male, 1 female, and 2 female left. Okay, get it? So this is how you do with complementary. So the answer for at least one female member will be 5/7. Okay. Okay. Lastly, we are talking about cards. So all the cards written with the letters from the word recurrence are put into a box. Okay, 2 cards are drawn at random from the box, one after the other without replacement. Okay, calculate the probability that the first card drawn has a letter R and the second card drawn has a letter N. Okay, first thing first. How many R you have here? You have 1, 2, 3. So R is actually basically 3/10, right? Okay, and N only got 1 N over here. So N is 1/10. But wait, if your first card is letter R, that means that your second card is letter N. If you take second card is letter N, how many card when you left in the box if you take away R? Okay, if you take away R, then you don't have any more R inside. Okay, then you are left with 9 cards inside. Okay, so this will be 3/10 multiplied by 1/9. Okay, so it'll be like this. So 3/10 times 1/9, so you get 1/30. Okay, next, the 2 cards drawn have the same letter. So what are the same letter we have? We have RR, okay, we have EE, we have CC. Okay, either one, so we use OR. So all the probability have to plus together. Okay, so how many R you have? You have 3 R. How many C you have? You have 2. How many E you have? You have 3. Okay, so it will be like this. So for R it will be 3/10, 10 cards, times 2/9. E also have 3, right? So E is the same probability with R. How about C? C only have 2. So it's 2 over 10 times 1 over 9. Okay, so you see 3 over 10 times 2 over 9 plus 3 over 10 times 2 over 9 plus 2 over 10 times 1 over 9. So in the end, you have 7 over 45. Okay, 7 over 45. So it's pretty easy, okay? You see this question, we don't draw the tree diagrams, okay? You still can get it easily. Okay, not everything you need to draw tree diagrams. So if you don't draw, it's hard for you to understand. Okay, so you need to find a way to let you understand it better. Okay, so the homework will be given to you guys later in the same post. Okay.